So this video is going to be used to review significant figures, which everybody loses points on. So this is going to serve as a good review, whether it is your first day, first month, first year, second year of chemistry. So what we're going to cover is we are going to cover what are significant figures, why do we need to use them in science, what's the point, how are sig figs calculated? So what I'm going to do is I'm going to go through the rules really quickly, and then I'm also going to give you a really easy shortcut because no teacher out there is going to ask you what the sig fig rules are, but they are going to ask you to figure out how many sig figs are in a number. Rounding with significant figures is going to be covered, and also calculations using significant figures. So first, what are significant figures? Well, they contribute to precision. And the difference really between chemistry class and math class is that we're going to be using equipment, and that equipment has some level of precision built in. So yeah, I mean, I could, if I wanted to, use a brick, right? See, look, that's a brick, to be able to calculate how heavy I am. But that's not really going to give me a very good answer. It's going to give me an answer in numbers of bricks, which is not helpful. There are lots of balances that are in my room. And if you take a look at this number down here, 13.2 is said to be precise to the nearest 0.1. So anytime you make a measurement with a number, you get to read directly off of that number. So let's say numbers of bricks, right? So 5 bricks. And then I get to estimate one uncertain digit. And that's going to be the one that I am going to decide what it is. Is it 5.5 bricks? Is it a third of a brick? Is it a quarter of a brick? That's going to be my decision. With digital balances, they do that for you. So in the case of the 13.2 number, that 0.2 is estimated by the piece of equipment. So who cares? Me, and therefore you. Scientists care because you know how pi is infinitely, it goes on and on and on forever. That's not really going to help me if I have to weigh out bricks and I need 0.00000000267 of a brick. I don't care. To me, that's not a brick. All right. So how are sig figs calculated? There's a bunch of rules that you can memorize if you want. There's 5 in particular that's given by most textbooks, or you can know a handy shortcut. So if you're a rules person, I'll give you the rules first. Here are some rules. So the first one says anything that's a regular number, so 1 through 9, those are going to be significant. So in this case, there's 4 sig figs. In this case, there's 1, 2, 3, 4, 5. In this case, there's 1. All of the rest of these have to deal with zeros. Sometimes zeros are significant and sometimes they're not. So in this case, zeros between non-zero numbers, these are sandwich zeros. There are 3 sig figs here because really if I can measure to the ones place, I must also be able to measure to the tenths place, right? So that 0 that's in between the 2 3s, that counts. In 8901, there are 4 significant figures, the 8, 9, and 1 because they're not zeros, and the 0 because it's smushed. And in this one, there are 6. Zeros at the front of a number are not significant. And that's because I can rewrite this number if I want to as 4.2 times 10 to the minus third. And you see what happened to those zeros is they get folded into this 10 to the minus third term. And the only numbers that we need in front are the 4 and the 2. Therefore, this one has 2 sig figs. This one that you can't really see anymore is 0.02804. That is 4 sig figs. And this one is also 4 sig figs. Zeros at the end of a number and to the right of a decimal are significant. If I'm measuring a crowd size and I say there's about 1,000 people there, I'm estimating, and I'm estimating all of these, okay? But if I say there are exactly 1,000 people, I would write it that way. That's why the decimal point is important. That means I went through and counted every single person and I counted 1,000. This number means, there's about 1,000. This one has, let's look at the examples. This one has 4 sig figs. This one has 3 sig figs. And this one has 1, 2, 3, 4, 5, 6 sig figs. Zeros at the end of a number and to the left of a decimal place might be significant. So again, this is an estimated crowd size-ish of about 2,000. That means that has 1 sig fig because it's estimated. This one means I went through and counted everybody because see the decimal point? That's how I know I've counted it all. That means there's 4 sig figs here. This 0 is a sandwich 0 between the ones, and there's no decimal point there. Oh, sad face. That means there are 3 sig figs in this example. Okay, we'll do some more. You'll get used to it. All right. If you don't want to memorize all of these nonsensical rules, then what you can do is called the box and dot method. It's fabulous. First thing you do is you start making a box around the number, and you start at the first number that's not a 0, okay? So here, my number is 0.007540. My first number is 7, and then you end your box at the last number that's not a 0, a 4. The other question you have to ask yourself is, does it have a decimal point? Because if it does, that 0 that's at the end, this guy right here, is significant. Then what you do is you count up everything that's in the box. Looks like there are 4 numbers in the box. That means there are 4 significant figures in that number. Easy peasy. So I'm going to give you a second. You can try these ones, and then I'll go through the answers. All right, answers for these ones. This one has first number not a 0. It's like no decimal place. 1, 2, 3. There's 5 there. Here's my box. 3. Here's my box. It's only around that 2. So sad. The 2 and the 9. This doesn't count for sig figs. Only the number in front of the times 10 does. So in this case, it's 3. Now this one is a tricky one, this 4 basketballs one. Now if I have 4 basketballs, 1, 2, 3, 4, I have 0 fractional basketballs. I don't have any extra, and I have exactly 4. In fact, I have 4.0 or 4.00 or 4.000, and I can keep going and going and going and going. So that means anytime you have a counting number, there are infinite sig figs. So in terms of chemistry, that could be numbers of atoms or molecules. Those are going to be infinitely significant. All right. So rounding significant figures. What we're going to do is we are going to count over ever many sig figs we get, and then we'll round the next number. So if it's 4 or lower, it's going to remain the same. If it's 5 or higher, we will round up. So for this one right here, round 29039 to 2 sig figs. Well, that means I get 1, 2. Those are the numbers I get to keep. Now I look at the next number. That next number is a 0. So what's going to happen is the 2 and the 9 stay the same, and I just fill everything else in. 2, 9, 0, 0, 0. That's my answer. That is 2 significant figures, and it's a rounded number. Now, I have students that try to round 29039 to 29. When in the world is 29,000 rounded to 29? That makes no sense. All right, let's try this one. Round to 1 sig fig. All right, these are all zeros, so they don't count. 3. And then I look next door, I see a 2. So that means my answer is going to be either 0.0003 or 3 times 10 to the minus 4, either one. Let's try this one. I'll let you try it. We're not going to do this. This is for in the classroom. Go ahead, try that one, and I'll get back to you. All right, this one to 1 sig fig. 1 sig fig here is going to be rounded up because of the 8. 3, 0, 0, 0, 0. Ta-da!